Question number 1 under variables and separable method. Now this is a special technique under partial differential equations. The question is, what is the solution of the partial differential equation ux is equal to 4 uy subject to the condition ux comma 0 is equal to 4 e power minus 2x. Now the idea behind the variables and separable method is that a PDE can be reduced to a system of ordinary differential equations which are much easier to solve. So let us see this problem. You assume the form of the solution to be u of xy is equal to capital X capital Y, where capital X is only a function of small x, capital Y is only a function of small y, hence the name separable method. Now if you differentiate this with respect to x, y will be a constant d capital X by d small x, uy, now capital X is a constant d capital Y by d small y. So with this assumed solution you generate the partial derivatives and now substitute in the given equation. So this equation becomes y dx by dx is equal to 4x dy by dy. Now let us do the separation. 1 by capital X dx by dx is equal to 4 by capital Y dy by dy. So you can see that separation has been done. Now equate them to some constant k. If you take this group, you can solve for capital X. If you take this group, you can solve for capital Y. So if you take this group, we can write 1 by capital X dx is equal to k d small x. That means there is another separation between capital X and small x. So if you integrate, you will get log x is equal to kx plus c1. So capital X is equal to e power kx plus c1. So in the assumed solution, capital X is now available. We will now take this group and find out capital Y. 1 by capital Y d capital Y is equal to k by 4 d small y. If you now integrate this, log y is equal to ky by 4 plus c2. So capital Y is equal to e power ky by 4 plus c2. So the capital Y in the assumed solution is available. Substitute the capital X capital Y in the assumed solution and you can write u of xy is equal to, if you multiply these two, e power c1 plus c2 can be condensed to capital A into e power kx plus ky by 4. So this can be some sort of general solution of the problem. Suppose we call this 1. We will now invoke this condition so that we can calculate a and k. So take u x comma 0 is equal to 4 e power minus 2x and apply it on equation 1. So put y is equal to 0 and we will get a e power kx is equal to 4 e power minus 2x. So direct comparison will give a is equal to 4 and k is equal to minus 2. All that we need to do is substitute a and k in this and that should be the end of the problem. So uxy is equal to 4 e power, kx is minus 2x, k by 4 will be minus 1 by 2, so minus y by 2. So you can see that option D for this problem is correct. Question number 2, another problem on the separation of variables. We have to solve 2ux plus 3uy is equal to 0 subject to the condition u0y is equal to 1 plus 2 e power minus 4y. So a little bit of complication compared to the last problem. Again we start with the assumed solution as u x comma y is equal to capital X capital Y. from which ux is equal to capital Y d capital X by d small x, uy is equal to capital X d capital Y by d small y. So take these derivatives and substitute in the given equation. So we'll have 2 capital Y dx by dx plus 3 capital X dy by dy is equal to 0. We can transfer one of the terms to the right hand side. 2 capital Y dx by dx is equal to minus 3 capital X dy by dy. So get the capital X this side, capital Y that side. We will have 2 by capital X dx by dx is equal to minus 3 by capital Y dy by dy. After this separation, you can use k as a common value. Take these two and you get capital X, take these two, you get capital Y. Suppose you take these two, you have 1 by x d capital X is equal to k by 2 dx. So if you integrate, log x is equal to kx by 2 plus c1. So capital X is equal to e power kx by 2 plus c1. If you take these two, 1 by capital Y dy is equal to minus k by 3 dy. This integration will give log y is equal to minus ky by 3 plus c2. So capital Y is equal to e power minus ky by 3 plus c2. So this capital X and this capital Y can be used in the assumed solution to get the general solution. So uxy is equal to, if you multiply these two, e power c1 plus c2 can be reduced to a e power kx by 2 minus ky by 3. If you impose this condition on this, we must be able to calculate the unknown constants. So if you apply u0y is equal to 1 plus 2 e power minus 4y, you will have a e power, because x is 0, this will disappear, minus ky by 3 is equal to 1 plus 2 e power minus 4y. But there is a small problem. We have one term here and two terms there. So this can be split as a1 e power minus k1 y by 3 plus a2 e power minus k2 y by 3 is equal to, we can give this an exponential form for comparison, 1 e power 0 y plus 2 e power minus 4 y. So this is the approach you must take. So compare these two terms, and you will have a1 is equal to 1, k1 is equal to 0, a2 is equal to 2, k2 is equal to 12. Now take this and go to the general solution. Basically, you write 1 as, again you will have to split this as uxy is equal to a1 e power k1 x by 2 minus k1 y by 3 plus a2 e power k2 x by 2 minus k2 y by 3. So use the values that are available to us, and you will get uxy is equal to a1 is 1, k1 is 0. Therefore, you will have directly this term, e power k1 is 0. So therefore, the whole of this becomes simply 1. Going to that term, a2 is 2, e power k2 by 2, that is 12 by 2 is 6x minus k2 by 3, 12 by 3 is 4y. So, this should be the answer to the problem, and if you watch, it will correspond to option number A. So, this is a problem with a little bit of complication. Question number 3. What is a possible solution of the partial differential equation ut is equal to c square uxx? Now, this is the famous one-dimensional heat diffusion equation, where u is a variable of temperature, t is a variable of time, and x is the variable of position. Well, this can be solved using the method of separation of variables. So, assume the form of the solution to be ux comma t is equal to capital X capital T, and get those partial derivatives from this equation. Ut is equal to capital X dt by dt, and uxx is equal to capital T d square x by dx square. Now, take this partial derivatives and substitute in the given equation. So, you will get x dt by dt is equal to c square t d square x by dx square. So, put the capital T and capital X on opposite sides. You will have 1 by capital T dt by dt is equal to c square by capital X d square x by dx square. Now, the separation of capital T, the x's and t's is now over. So, you can now have two options of equating to plus k square or minus k square. Now, let us take one case, let us take minus k squared, right. So, if you take one by capital T dt by dt is equal to c square by x d square by dx square is equal to minus k squared, you will get one type of solution. Let us try with this. If we are lucky and get the correct option, then we do not have to investigate the plus k square case, otherwise we will investigate the plus k square case. So, let us begin with determination of capital X. So, from here we can write d square capital X by dx square is equal to minus k square by c square capital X. Now, if you observe this, this is an ordinary differential equation of the second order, which looks like this. And we all know from the theory of ordinary differential equations that the solution consists only of the complementary function, no particular integral, because it is homogeneous. So, capital X is equal to c1 cos k by cx plus c2 sin k by cx. Now, again let us take this group, that is 1 by capital T dt by dt is equal to minus k squared. This is a first order situation. So, we will get log t is equal to minus k square t plus c3, c1, c2, now c3. So, capital T is equal to e power minus k square t plus c3. So, this is capital T. So, take the capital X and capital T and substitute in the assumed form of the solution. So, u of x comma t is equal to, so when you multiply this with this, e power c3 into e power minus k square t multiplied with c1 cos k by cx plus c2 sin k by cx. So, now you can minimize the constants. These two can be combined, these two can be combined, you call them capital A, capital B, and u x comma t is equal to e power minus k square t into a cos k by cx plus b sin k by cx. So, this is one of the possible solutions, that is if you take minus k square as the constant of equality. Sometimes more than one correct option may be present. In such a case, you may have to try with plus k squared. So, you can see from the options that this answer is available as option B. Question number 4. What is a possible solution of the partial differential equation uxx plus uyy is equal to 0? All of you perhaps may be knowing this is called the Laplace's equation in 2 dimensions. Well, the meaning of this is that it governs the distribution of temperature in rectangular plates in the steady state condition. Now, our problem is to find a possible solution for this one. So, you start with uxy is equal to capital X capital Y and get the partial derivatives. Uxx is equal to capital Y d square x by dx square, uyy is equal to capital X d square y by dy square. Now, take these partial derivatives, substitute in the given equation. So, you will have y d square x by dx squared plus x d square y by dy squared is equal to 0. So, now we will do the separation. 1 by capital X d square x by dx squared is equal to minus 1 by y d square capital Y by dy squared. Again, you have two options. Again, we will try with minus k square and test the solutions. If we are lucky, well and good. Otherwise, we will try the plus k square option. So, suppose you consider 1 by capital X d square x by dx squared is equal to minus 1 by y d square y by dy squared is equal to minus k squared. We will take these two first and determine capital X, then we will take these two and determine capital Y. So, if you take 1 by capital X d square x by dx squared is equal to minus k squared and adjust the terms, you will get d square plus k square into capital X is equal to 0. And you know the roots of this are purely imaginary. So, d is equal to plus or minus I k. So, all of you know from the theory of ordinary differential equations, capital X is C1 cos kx plus C2 sin kx. On the other hand, when you take minus 1 by y d square y by dy square is equal to minus k squared, you will have 1 by y d square y by dy square is equal to k square. Adjust the terms. Now, you will have the differential equation d square minus k square into y is equal to 0. So, capital Y is equal to, from here d is equal to plus or minus k, real and unequal roots. So, capital Y is equal to C1 e power ky plus C2 e power minus ky. So, please observe the change in the pattern of the solutions. With imaginary d, you will get cosine, that is harmonics, and here you will get exponentials. Now, take this capital X, capital Y and substitute in the assumed solution. So, therefore, a possible solution will be uxy is equal to C1 cos kx plus C2 sin kx multiplied by C3 e power ky plus C4 e power minus ky. This corresponds to option C. As I told you, if this option is not found, change your approach, go to plus k square and then derive.